Okay, in this video, we are going to graph and we're going to compare the graph of y is equal to 2 to the x and y is equal to 1/2 to the x. So let's first graph y is equal to 2 to the x. I'll do 2 to the x on this side and 1/2 to the x on this side. Okay, so we're going to make a t-table to start off with. Now if I look at this, even though I don't write it in there, this is really 1 times 2 to the x. So my a is going to be 1 and my b is going to be 2 if I'm looking at my general form of an exponential function. And because my b is greater than 1, I know my finished product when I'm done graphing this, it should be an increasing exponential function because it's going up left to right. And I also know because my a is 1 that it should cross the y-axis at 1. So I'm going to just plot some points from -2 to +2. So I'm going to plug those into 2 to the x. So if I take -2 and plug it in to 2 to the x, that gives me 2 to the -2. And remember, with negative exponents, that means you flip your fraction upside down. So if I have, ignore the negative for a second, if I have 2 to the 2, that's 4, but the negative says to flip it upside down, so this is going to give me 1/4. Then I'm going to take 2 to the -1. 2 to the first is 2, but then the negative in the exponent says to flip it upside down. So that's going to give me 1/2. 2 to the 0 is going to be 1, right? Anything to the power of 0, unless it's 0 to the 0, that's undefined. But anything else to the 0 power is going to be 1. Then if I plug in 1, I get 2 to the first, which is 2. And then if I plug in 2, I get 2 to the second, which is 4. So if I put this all together, okay, so I have -2 and then 1/4. So somewhere right here. Then I have -1 and 1/2. So somewhere right here. And then I have the point 0, 1. And then I have the point 1, 2. And then I have the point 2, 4. I have to go up a couple more here. So my graph is going to flatten out here. Remember, unless we shift it and we have a plus or minus something on the outside of that function, it's not going to shift. I'm going to have a horizontal asymptote at the x-axis. So it's going to flatten out here, and then it's going to increase and get bigger that way. And notice my features of the graph. We said that it should have a y-intercept at 1 because that's my value of a, and we have that. Okay, so we have a horizontal asymptote at y equals 0. We have a y-intercept, not an x-intercept, at the point 0, 1. And it's increasing because b is greater than 1. Okay, now if we look at this other function, I'm going to plot the same points. Okay, I'm going to plug in -2 and for x, so I have 1/2 to the power of -2. So if I take 1/2 and square it, that's 1/2 times 1/2, which is 1/4. And the negative sign tells me to flip it upside down. So the 1/4 becomes a 4. Now I'm going to plug in -1. So I have 1/2 to the -1. 1/2 to the +1 would just be 1/2. And the negative in the exponent tells me to flip it upside down, so this becomes a 2. Okay, and then let's see, if I plug in 0, I have 1/2 to the 0, which is 1. And then if I plug in 1, I get 1/2 to the power of 1, which is 1/2. And then 1/2 to the power of 2 would be 1/4. Now, if I put this all together, I'm going to plot the point -2, 4. I'm going to plot the point -1, 2. I'm going to plot the point 1 or 0, 1. I'm going to plot the point 1, 1/2. Whoops, darn it. There we go. So 1, 1/2, and then 2 and 1/4. So again, I'm going to have a horizontal asymptote at the x-axis. And notice now that I still have a y-intercept at 0, 1, because even though I don't write it in here, I have a 1 times 1/2. My a is 1. Since my b is a 1/2, which is less than 1, this is going to be decreasing. So notice that it's decreasing. It's going down left to right. Now, something that I also want to tie in with this, and this ties in with graph shifting too, if I take 2 to the x, which is this first graph that we graphed, and I flip it over the y-axis. When I flip something over the y-axis, that means all the values of my x's change signs. So if I flip over the x-axis, I'm going to get 2 to the -x. If I flip it this way, it's going to look something like this. So this is 2 to the power of -x if I flip it over the y-axis. But remember, with negative exponents tells me that I flip that fraction upside down. So instead of having a 2 to the -x, if I want to get rid of that negative in the exponent, I flip my 2 upside down. So instead of having a 2, I have a 1/2 to the x. And this is the same graph as 1/2 to the x. It's just written in a different way. So you could also have your function be decreasing if you have a negative in front of the x, because that means it's been flipped over the y-axis. So it's nice to make that connection with the graph shifting with the other functions, you know, to see how, if we flip it over the x-axis, how that changes the function. And in this case, it's going to make my value of b become less than 1 because I'm flipping it upside down.